Right, this video is going to be going over our practice test, and we are just looking at the non-calculator portion in this video. So for our first question, we are asked to integrate. So let's go ahead and see if we can get the right answer here. So when we integrate, this is where we add 1 to the exponent, and that tells us what to divide by. So we're going to have x cubed over 3 minus 2x squared over 2, and that whole part is going to be evaluated from -1 to 3. So if we plug in 3, we're going to have 27 over 3 minus 9, and then that's going to be minus -1/3, and then minus, it looks like we're going to get a +1 there. Now, instead of trying to find a common denominator here, I would just go through and subtract what I could. So 27 minus a -1/3, so 27 minus a negative, so that's going to be 28 over 3, and then -9 minus a -1, so that's going to be a -8. And now we get a common denominator of 3, so that 8 is going to turn to 24. So it looks like we should get 4/3 for a solution. For question 2, it looks like we need the product rule. So let's find what would f prime first look like. So f prime at x is going to be first times the derivative of the second, so we're going to get 3x squared, plus the second times the derivative of the first, and the derivative of the first is still going to be e to the stuff, but then times stuff prime. And then from here we need to find f prime at 2, so we're going to have e to the 4th times, we plug in 2, we're going to get 12, plus 8, 9 times 2, 18, e to the 4th. And so when we collect our like terms here, it looks like we're going to get answer choice D. All right, moving on for the next question, number 3. So f is differentiable was an approximation for 2.1. And so we need to first, on this one, write our equation of our tangent line. So our tangent line, we have our x and y values there. So we have y minus 4 equals 2 times, or I'm sorry, not 2, that's -1/2, isn't it? -1/2 times x minus 2. And then we are going to try to find that approximation for 2.1, so we need to plug in 2.1. So we have y equals, or really let's make that f at 2.1 equals -1/2 times, well, if I plug in 2.1 minus 2, I have 0.1 left, and then plus 4. And so now we have to do some math part here. That -1/2, that's really -0.5. So that's going to be -0.05 once I multiply that, plus 4. So it looks like we're going to get answer choice B. For number 4, we need to see how many relative extrema does G have? In other words, how many relative mins and maxes? So here, don't let the terms bother you if you need to, and I highly recommend that you do this. Where you see relative extrema, remind yourself. That means you're talking about a relative min and a relative max. So make sure you do a good reminder there of that. All right, so all a relative min and max would be is a classified critical point. So with a critical point, the first thing we need to do is find the first derivative, which is going to be 4x cubed plus 12x squared. And then to find the critical point, we do set this equal to 0 and factor. So we factored out that 4. So we're going to have x plus 3 left. And then looking at this, we have x equals 0 and x equals -3. But there's a big hint here that since we have this 4x squared, that generated x being 0. That x is always positive since it's squared. So if it's always positive, that means there's not going to be a sign change there. So that means that really this is not going to be a relative extrema. It's a critical point, but we can't classify it as relative min or max. So the only one that we got from this that's possible was x equals 3. So for number 4, the answer should be B. Okay, number 5. Now number 5 is a tricky problem. If we're not careful, we'll do the wrong formula here. We're asked for what is the average velocity. So for this is the same thing as average value. And the average value of a function, 1 over b minus a, the integral from a to b of just whatever our function is. That's your average value. So for this one, for our average value, we need to integrate our velocity function. So we're going to integrate from time of 1 to 3 of 2 minus t squared dt. But since it says average, we're going to have to divide that by 3 minus 1. So really we have 1/2 times, we have 2 times t minus, and this is going to be t cubed over 3. And this is going to be evaluated from 1 to 3. So let's go ahead and go plug in and see what we get. We have 1/2 times. If we plug in 3, we're going to get 6 minus 9 minus, that's your top endpoint, minus your bottom endpoint. So that's going to be 2 minus 1/3. And so continuing to work this out, because darn it, we have to. So we have 1/2 times -3 minus, well, 2 minus 1/3 is going to be 1 2/3. So that's going to be 5/3, isn't it? And so over here, we're going to have to get a common denominator. And so we're going to end up with that over 3. So what is that going to be? It's going to be 9. So I'm about to run out of room, I think. So we're going to end up here with 1/2 times -9 minus 5. So -14 over 3. And fortunately, the 2 and the 14 will cancel. So I have -7 over 3, which looks like that is answer choice C. All right, moving on. So for our next problem, it looks like we have a trapezoidal sum. And so we're trying to find the approximate number of tons of material in the first 9 hours. All right, so for our trapezoidal sum, this is where really up here in our chart, we relied on the differences here. That was going to be our height. And here was our base 1 plus base 2. So let's go ahead and do that sum. So let's go ahead and find our difference. So we have 1/2. The height would be the difference here, so 2 times the sum of 15 and 9 plus, and then our next would be 1/2 times the height here is going to be 5 times the sum of 9 and 5 plus 1/2 times 2 times 5 plus 4, so that's 9. All right, and so the rest of this is just ugly math. So we have 15, those cancel, 15 and 9, 24, plus, let's see, oh dear, we've got 5 halves, but 5 and 9's 14. So 7 times 5, 35, plus 9. And so let's see, we're going to have, that's going to be what, 59 plus 9. So good old 68. So answer choice A. Now number 7, we are not to the area, or bounded area, but I'm going to go ahead and work this one out. And the first thing you need to do is sketch your curve, and you're given first y equals 6x squared minus 18x. And we know that's a parabola, but we need to know where this crosses the x-axis. And so we know we have a parabola that crosses the x-axis when x is 0 and when x is 3. And if we found the vertex, the x-coordinate of the vertex is really just right in between these. So the x-coordinate of the vertex would be 1.5. So we have a nice parabola that goes through the origin and swaps back up here. Now again, you all know me, I can't draw. That's about as good as it's going to get. All right, and then we need to draw our line. That's going to be the first one. And now let's take care of our line. With our line y equals -6, we know that we have a slope of -6, and we are going to have a y-intercept, or it's going to go through the origin. So we know our line's here. But now if we extend this line and we know it has a negative slope, it looks like we're going to intersect our parabola in more than one place, more than just at 0, 0. So we need to see what the value, x value is at that point. So in order to do that, we just set our functions equal to each other. So 6x squared minus 18x equals -6x. And again, we're setting them equal because their x values are equal at that particular point. So that means I have 6x squared minus 12x equals 0. And let's see, we can take out a 6x, x minus 2. So again, we already knew they would intersect at 0, but here's the other x value. They intersect at 2. So really, I have two areas that are bounded that we need to find. The first area that's bounded would be from here and here. But then my second area is over on the outside portion. It's from here to here. And so we are going to have to set up two different integrals to find those values. So the first integral we would set up, and we always follow the pattern from when we integrate, it's going to be top minus bottom. So the top function here is our line. So we have -6x minus the bottom function, which was our parabola. So minus 6x squared, and we can go ahead and flip that, plus 18x. Now we're integrating from what to what? It told us in the directions from x equals 1 to x equals 3, but we've got a stopping point in there. So really we're going to have to stop, and we're going to integrate from 1 to 2. So 1 to 2 plus, and then we're going to have to get the last part of that. So plus, and then we will integrate, of course we've got all of that, from 2 to 3, but this time a different function's on top. The parabola is on top. So we're going to take our parabola, 6x squared minus 18x, and then I'll subtract the line, so minus a -6x or plus 6x. And so that's going to be the setup of this problem. And after you go through and you integrate and you add those, you should get answer choice B. But again, that's the next to the very last thing that we're going to do. So I know we don't know how to do that right now, but that's a great preview of what is coming. All right, so for number 8, the function g is defined by blah. All right, and if the line tangent to the graph of G at x equals 1 is parallel to the line that contains those points, well, what is the value of B? Well, the first thing we might need to do would be to find the slope of the line that is parallel here. So our M value, we're going to have 4 minus negative 2 over 3 minus 0. So that slope is 2. And so let's see, if the line is tangent to the graph at x equals 1, oh, all right, so now we have enough information we could just about set up and solve. Well, we know this derivative, g prime at x, is going to be 2x plus b. And we know the derivative value has to be equal to 2 because we're talking parallel lines here, folks. And so that's going to give me 2 equals 2 times negative 1 plus b. So it looks like our b value is going to have to be 4, which is D. Okay, our next problem looks so strange because it's like, what in the world does this have to do with this? But believe it or not, we can do both of those. We can make those work together. The first thing we might need to do is to sketch a picture of f of x. And the reason why is because what we're asked to find would be some bounded area. So if we sketch f of x equals the absolute value of x over x, and we talked about this earlier in the year when we were finding limits. Well, what's going to happen here with this is we can do a t-chart, and after we do that, and I encourage you to do the t-chart if you don't see right off what's going to happen, we're going to have this line here at negative 1, because if I plug in, let's say, negative 2, I'm going to get the absolute value of negative 2 divided by negative 2, which is negative 1. Well, then, for the positive side, we're always going to be stuck at 1. Now, notice I'm putting open circles here at the 0 because the absolute value of 0 over 0, that's just nonsense. Nobody knows what in the world that is. But we're also told right here. So they're going to give us that value. So if we integrate from negative 5 to 3, then what we're doing is saying, okay, from way out here at negative 5 to 3, well, I can get super duper close here. And if I trace off this shape, notice that I end up with a rectangle. And we know the length times width. Well, let's see, the length is 5, the width is 1. Folks, that's my husband. He just got home from church. I'm sorry. So that's going to be 5 there. And then over on the other side, we have from 0 to 3. So again, we have another rectangle from 0 to 3. And if we find that area, well, that's again length times width. So we're going to get 3 times 1. Now, we have to keep in mind when we're combining these areas, this portion over here was below the x-axis, so it's negative. So we have negative 5 plus 3, which is going to generate for us a negative 2. And that problem looked to be a lot worse than what it actually was. All right, moving on to number 10. Number 10 is a U sub problem. They're saying if we let U be this, then what is this integral going to be? Well, the first thing we need to check, notice all of my answers, they're in terms of U. So the chances of U having the same exact endpoints as x are really unlikely, but let's go ahead and check our endpoints real quick, and that should eliminate a few answers for us. So U is equal to 2x minus 1, and so U equals 2 times 3 minus 1, which is going to tell me my upper endpoint is 5, which very quickly eliminates A and B. So, and apparently from C and D's answer choices, the bottom is going to be 3. So we don't have to worry about finish checking that. Now the other thing is once we let U be 2x minus 1, we have to see, well, what is du going to be, which is 2 dx. And so notice we're going to have to balance that 2 with a 1/2 on the outside, which means I have answer choice D. Okay, and let's see our next problem, number 11. And again, another problem that seems pretty doggone tricky. If we're integrating our function from 2 to 12, and it's like, my gosh, what in the world? How in the world am I going to do that? Well, we're going to draw a rectangle. Okay, I'm going to try to draw, but we all know me and my awesome drawing here. All right, we're going to draw, it kind of looks like a taco, but we're drawing a rectangle around our semicircle, and we're looking for this bounded area out here, which is really going to be the area of the semicircle, and then we need to find the area of the rectangle and subtract the two. Well, the area of the semicircle, we have pi times the radius squared. Well, our radius squared, well, let's see how far apart these two things are. From 2 to 12, that's 10, so half of that's 5, but then 5 squared is 25, and we want half of that for a semicircle. So I know this inside here is 25 pi over 2. Now let's go find the area of the rectangle. Well, the area of the rectangle, length times width, so the length is going to be 10. Width is 6, so that means the area of the rectangle is going to be 60. And the area of the semicircle, we found that to be 25 pi over 2. So looking at our answer choices, we are going to be kind of somewhere between C and D. But now we know we need to take the area of the rectangle, which was 60, and we need to subtract from it the area of the semicircle, which was 25 pi over 2. But we have one small thing here, and that makes us, we want to grab D as our answer choice, but all of this was bounded under the x-axis. So we need to put a negative out there, which means we're going to flip our signs, and that's going to give us answer choice C. For number 12, we have a particle motion problem, which those are usually pretty cool. All right, so let's see if we can figure out the object's position. So we're giving it acceleration, and then we need to backtrack. We need to undo the acceleration or the derivative. And actually, we have to undo it twice. So if we integrate, uh-oh, my pen's not working. Hang on. If we integrate acceleration, then that's going to give us back our velocity. And if we integrate velocity, we get back our position. So let's go ahead and integrate our acceleration function. Well, our acceleration function is 6 times t. And let's see, dt. And that's going to give us velocity. And so if we go ahead and do the derivative here, it looks like, let's see, we're going to add 1 to our exponent. So I get 2. So that's going to be 3t squared plus c, because we are doing our indefinite integration. And then we were told some initial values. We were told that when time is 0, the object's velocity is going to be 10. So it looks like c is 10. So now we have our velocity function. So velocity, that's going to give us 3t squared plus 10. All right, and now we need to integrate velocity because that'll give us position. So let's go ahead and integrate 3t squared plus 10 dt. And so that's going to generate for us our position function. So our position function is going to be, and so that's going to give me t cubed plus 10 times t plus c again because we need to use our initial condition, and we were told that at time 0 that our object's position is 7. And so if we look at this, our time's going to be all blocked out to 0. So our position function, x at t, is going to be t cubed plus 10t plus 7. Now, using that position function, what is the object's position at time equals 2? So x at 2 equals, and 2 cubed is going to give me 8, plus 20 plus 7. So it looks like we're going to end up with 35. So that's going to be answer choice D. All right, number 13 wants us to find the third derivative. So let's go through and do that. So the first derivative, y prime, that's going to be, well, the derivative of cosine's negative sine x minus, and the derivative of natural log of 2x. Well, that's going to be stuff prime over stuff. So that's going to simplify. I have negative sine x minus, and I'm going to cancel the 2's, but then I'm going to flip over x and make it to the negative 1. So now let's do the second derivative, y double prime. So the derivative of negative sine of x is going to be negative cosine x. And the derivative here, we'll move that negative 1 to the front, and then we'll subtract 1. So we have negative 2. So now let's do our third derivative. And the derivative of negative cosine, that's going to generate a positive sine. So from there, we can cross out a couple of answer choices. I don't know why I crossed out A. Let's undo that. So I know I'm going to have to cross out B and D. And here, if we multiply down, we see we get a negative 2, and then x to the negative 3, and that's going to simplify to be answer choice A. Good thing I didn't mark that one out. Goodness. All right, question 14 is a very tough question, but we're going to see if we can't get through it. And so we're given the graph of f, and we're told that g is an antiderivative of f, and such that g at 2 is 5, and we have to figure out how many values of c exist such that g at c is 3. So in order to do that, we're going to have to find some bounded area. And so we are going to have to do some integration. And our best thing to do with that integration is to include 2, so that when we do our endpoints, we know at least part of the equation and we'll be able to solve. All right, so knowing that we have to use 2, the first solution that you're going to look for would be probably, let's start as far left as we can go. So let's start from 0 to 2 of g at t dt. And so that's going to generate for us a g at 2 minus g at 0. And we know that g at 2 is going to be 5, so 5 minus g at 0. Now we need to figure out, well, what is that equal to? Well, let's go back up and calculate our area. 1/2 base times height. And if we do that, and again, keep in mind we're looking for this through here. And so 1/2 base times height, so that's going to give us an area, it looks like, of 2. So we also know all of this is equal to 2. And so that very quickly works out, and we see that g at 0 would have to be 3. So there's one of them. So moving on with the next one. The next one, again, we have to keep in mind that we need to incorporate 2 as much as we can. So by trial and error, I figured out that the next one we would have to integrate would be from 2 to 4. And g at t dt, or g at whatever D whatever that you want. And so that's going to give us G at 4 minus G at 2. And so we know G at 4 minus 5, but we also need to calculate that area. So keep in mind we're looking at the bounded area from 2 to 4. And if we go through 1/2 base times height again, so let's calculate that area. 1/2 base is 2, the height is 2. And so this bounded area down here is going to be a -2, negative because we're below the x-axis. So that's another piece in our equation. We know that's equal to -2. And then once we solve this, we see that G at 4 is going to have to be equal to 3. So there's another one. But wait, there's more. There is another one. So, and this one you don't see right off, as if we saw the other two right off, but for this one, you kind of have to use the intermediate value theorem, and we'll review that. But we do still set up some integration. We need to integrate from 2 to 5, G at t dt. And let's see, when we integrate there, we're going to get G at 5 minus G at 2. Move my screen over. And again, we know G at 2 has a value of 5. So we have G at 5 minus 5. Now we need to find out also, well, what does that equal? So we're going to be integrating from 2 all the way over to 5. So now we're looking at this big triangle here from 2 to 5. So again, 1/2. Our base is now 1, 2, 3, and our height is 2. So it looks like we're going to be getting 3 there. So here we're going to have 3, and it's going to be negative because we are below the x-axis. And so here we see that G at 5 is going to be equal to 2. And we have one last part that we need to integrate, and that's going to be from 2 to 6, as we are progressing across our shape. So we need to integrate from 2 to 6, G at t dt. And so again, we know that's going to give us G at 6 minus G at 2, which is 5. But then we have to backtrack and see that G at, from 2 to 6, well, we know 2 to 5. We found that just a second ago. We saw that that was going to be -3. So now we need to find the area of this triangle. Again, 1/2. Our base is 1, and this time our height is 4. So it looks like we're going to get 2 for that bounded area. So if we come back over here, we see that we have 2 for that one area, but then we also had, let's see, +2, and then we had -3. So that's going to be a -1. So we have G at 6 is equal to 4. Now this is why I said we have the intermediate value theorem. We know that our function is continuous, so by the intermediate value theorem, again, this is where if we wanted just for grins to plot this, we have an ordered pair 2 and then 5. So we have a point here, and then we have a point over here at 6, 4. So it's up here a little bit. And so if we have a continuous function, then this is saying that, hey, if I have all of these y values and x values present, then there has to be a c value somewhere between 5 and 6, so that G at that c value is somewhere between 2 and 4. And so that's going to be our third and final value. So this is going to be answer choice D. All right, problem 15 is much easier. Please don't let question 14 discourage you. That really should be a BC Cal question. All right, so for 15, we're really just trying to find the C value so that we're continuous. So our quick way of getting through that is we look at the limit from the left of the point in question of our function. And so the limit from that left side is going to be 6 plus c. And then we look at our limit from the right. So as x approaches 1 from the right of our function. And that's going to give us 9 plus 2 natural log 1. The natural log of 1 is always 0, so that whole part goes out to 0. And then we just set these two equal to each other because that would have to be true if we were continuous. So we get C to be 3. So my answer choice is B. Okay, for number 16, we're matching the slope field to the differential equation. And so with these problems, it's good to keep in mind your quadrant values as far as positives and negatives. So I always go through a very quick, well, that looks terrible. Let me draw a better X and Y axis. I just go through a quick review of my signs. I know both X and Y are positive in the first quadrant. So a positive and a positive. So all of my slopes here in the first quadrant, they all should be positive. So they should be tilted upward. And so I would go look in our first quadrant. So answer choice A is still okay. Answer choice B is definitely out the window. All of those are negative. Okay, and looking at C would have to still be there. Those are all positive slopes. And D is still positive slopes. So that's going to be okay. So let's look at our next quadrant, quadrant 2. Quadrant 2, X is usually negative and Y is positive, but since X is squared, that means that we're going to have positive plus a positive. So all of my slopes in the second quadrant have to be positive. So notice that that automatically throws out question or answer choice A, because these slopes down through here are negative. Okay, and let's see, all of them have to be positive in that second quadrant. So that, hey, look at there, that also throws out C because I have negative slopes through there. So it looks like the only answer choice left here is going to be D, and that's going to be our correct answer. For this question, all right, so the first thing we're going to do is find our derivatives. So our first derivative is going to be 3e to the 3x minus 5. And then our second derivative, that's going to give us 9e to the 3x. And now we have to try to figure out which one of these values would be true. Now the key to this is this constant value through here. So I'm going to take my y double prime, which is 9e to the 3x, and then I'm either going to subtract. All of those are subtractions, so I'm going to subtract, and when I subtract, I'm going to have my y prime, but notice I left a space because, again, I'm really just plugging in to see which one of these is going to give me a true statement. So I have 3e to the 3x minus 5. And all of this, either I'm going to add or subtract 15 or add or subtract 5, and I need to get 0. Well, the only way this 9e to the 3x is going to cancel out is if I have a 3 in the front here. Because when I do my distributive property, that's going to give me negative 9e to the 3x. So those would cancel. So that's telling me C and D are out. And then if I continue with my distributive property, I'm going to have a positive 15. So I'm going to need a negative 15 to cancel that out. So that tells me we have to have answer choice A. Right, for answer choice, or for number 18, we have to find the derivative of inverse sine. So f prime here, f prime at x, that's going to be equal to, well, let's see, our derivative of the inverse sine is going to be 1 over the square root of 1 minus x squared. And so I hope I'm remembering that right. We're about to see if I get the wrong answer, right? So f prime is going to be the square root of 3 over 2. And so we have to make that awesome substitution here. So I'm going to have 1 minus, well, if I square all of that, I get 3 over 4. And so let's see, that's going to give me 1 over the square root of, let's see, 1 minus 3/4 is a fourth, which is a half. 1 divided by a half is 2. So it looks like 18 should be answer choice D. Okay, number 19, as with any limit, we need to do a direct substitution. And if we do a direct substitution, we should get 0 over 0, which then implies that we need to do L'Hopital's rule. And L'Hopital rule is a great, nice little, I wrote that endpoint backwards. As x approaches e. L'Hopital's rule is how we always want to take derivatives. So x to the 20th, that's going to be 20x to the 19th minus 3. Everything over here goes out to 0 because they're all constant values, and the denominator goes out to 1. So if we evaluate our limit now, which makes that a whole lot easier, that's going to be 20e to the 19 minus 3, which is answer choice B. And moving on to 19, we need to find the second derivative value at 1. So when we find that derivative, let's see, we are going to end up with our second derivative, dy over dx squared, is going to be equal to 3y squared dy dx. And so we need to find our dy dx value. We already know our y value, so our dy dx value is going to be 11. So let's see, our second derivative value then is going to be 3 times 11 squared. Oh, no, 3 times 2 squared, my goodness. Times 11. And so that's going to give us 12 times 11, which is going to be 132. So that's going to be answer choice C. Okay, so for 21, we have a table of values, and we're asked about the value of h prime at 1, and so we need to find what the derivative of h does look like. And over on this other side, we're going to have our chain rule. So because we have a function inside of a function, so with chain rule, we address the outside derivative first, and then that's times the inside derivative. And now we're trying to find h prime at 1. So h prime at 1 would be f prime of g at 1. Well, g at 1, it looks like it's going to be 3 times g prime at 1. Well, g prime at 1 is negative 2. And so finally, we do need to find f prime at 3, which is 7. So I have 7 times negative 2, which is going to give us negative 14. Right, and 22, it looks like we're going to have to solve our differential equations. So this is where we would need to separate and integrate and then add c and find c. We have dy, and we would multiply our y over. So we have y dy equals x plus 1 dx. This is multiple choice, so it's okay to go ahead and integrate here. So that's going to give me y squared over 2, or 1/2 y squared, equals 1/2 x squared plus x plus c. And notice here we're not seeing that just yet, so we need to continue our solving process. And we're going to multiply everything through by 2. So that's going to be x squared plus, well, let's back up. Let's use our initial conditions. That might go by a little bit better. Our initial condition, f at 0 is -2. So if we plug in -2 here, I'm going to have 1/2 times 4. And all of the x values get wiped out because it's 0. So we see that c is 2. So now we can go back and substitute in. And I'm going to pull this equation down. So I have 1/2 y squared equals 1/2 x squared plus x plus 2. Let's multiply everything through by 2 to get rid of those fractions. Plus 2x plus 4. And now we're going to take the square root, and notice that we see pretty quick that we've got to pick answer choice C or D. And to know which answer choice should be correct, you need to look at the sign of y, because we have to ensure that our solution curve goes through that point. So our answer choice is C. And for number 24, if we go ahead and do a straight substitution with 3, then we will get 0 over 0. And so since we have 0 over 0, L'Hopital's rule can be used. So we're going to have the limit as x approaches 3. The derivative of tangent is going to be secant squared of x minus 3 times the derivative of x minus 3, which is just going to be 1. And then the same is true with the denominator. If we take the derivative of 3e to the x minus 3, we're going to have 3e to the x minus 3 times the derivative of x minus 3, which is just 1. And then we have minus 1. So now if we substitute in 3, we're going to have secant squared of 0 over, well, if we plug in here, that's going to be e to the 0, which is 1. So 3 minus 1 is going to give us 2. And secant of 0 is 1. And 1 over 2, we have 1/2. So our answer is C. All right, number 25. We have a derivative value given to us. And we're told 2 ordered pairs here. And we want to know for what value of x inside the interval 1 to 3 satisfies the conclusion of the mean value theorem. Well, the conclusion of the mean value theorem, let's just write that out to help us remember. The mean value theorem is telling us f prime at c for some c inside the interval a, b is equal to f at b minus f at a all over b minus a. So that's going to be our conclusion. Well, we have 2 ordered pairs, so let's go ahead and see, well, what does that derivative have to be equal to? And we're given the points 1, 9 and 3, 11. So again, we have the ordered pair 1, 9. We have the ordered pair 3, 11. So let's see, what is the slope of the line between those points? So 11 minus 9 over 3 minus 1. So we have 1. So to satisfy the mean value theorem, we have to find some value in between the interval, or in the interval 1, 3, so that my derivative is equal to 1. So we're going to say 1 equals 3x squared minus 6 over x squared. And let's multiply both sides by x squared. So I have x squared equals 3x squared minus 6. So negative 2x squared equals negative 6. So x is going to be plus or minus the square root of 3. But keep in mind, we're looking inside the interval from positive 1 to 3. So we need to choose the positive square root of 3. So we have answer choice B. Now, problem 26 is a little bit more difficult than what we've seen in the past, and that's because we can't factor the numerator and cancel anything, and we can't really do a u substitution here. So that's going to leave us with having to do what's called synthetic division. So what we're going to do is take the coefficients of the numerator. So we have 1, negative 5. That's all of my coefficients. And then I'm going to go through and divide these, and that's why it's called synthetic division. It looks really strange. Take the denominator, set that equal to 0, and solve. So x is negative 2. And so I've already dropped this 1, so we're going to take that negative 2 and multiply to the 1. We get negative 2. I combine these terms, I get negative 3. We do the same thing again. We're going to multiply negative 2 and negative 3, so we get 6. And we are left with a 1. So what this means is now I have two things I can integrate here. I'm going to integrate from 1 to 2 still, but then I'm going to use these are coefficients, and I'm going to drop this down a power. So that's going to be integrating x minus 3. And then we're going to have plus, and then we're going to integrate from 1 to 2 still, but this right here is a remainder. So it's going to turn into 1 over x plus 2. Okay, now let's go ahead and integrate. So x minus 3, if we integrate this, we're going to have 1/2 x squared minus 3x. And we are going to evaluate that from 1 to 2. And then over on this other side, notice 1 over x plus 2. If we integrate that, we're going to have the natural log, absolute value of x plus 2. And we're going to evaluate that from 1 to 2. Right, so let's see what we end up with here. And notice that once we do this, there's only 2 answer choices that have natural log in them. So let's go ahead and cancel out those. And really, look at the natural log. Let's go ahead and just focus on this other side, because if we have our natural logarithm figured out, then we'll have our final answer. So we're going to plug in our 2. So we're going to have natural log, the absolute value of 4. So it's the top minus the bottom. So natural log, the absolute value of 3. And so when we put these together, it's 4 over 3. So that's going to give us answer choice A. Okay, for our next problem, we have a related rates problem, and they've given us our formula here. So let's go ahead and find our area. So we have dA dt. It's going to be equal to 12 pi dH dt minus 2 pi h, and again dH dt. So don't forget that. And so we're also told that when the height is 3 meters, then the water is decreasing at a rate of 1/2 meter per meter per minute. So we have to find the rate of change in the area. So that's going to be 12 pi times 1/2 minus 2 pi times 3 times 1/2. So when we put these together, notice the 2's here will cancel. And we also have the 2 over here canceling into 12, leaving 6. So it looks like we're going to end up with 3 pi. And that's going to be answer choice A. Okay, for our next question, we've given the vertices of a triangle, and those vertices are on the x-axis, so we have something like this. And we have the base from 1 out here to 5. So 1 to 5. So we know the base length here is 4. And so we want to know the third vertex is on the graph of this. And we want to know well, what is the maximum area? So that maximum area is going to occur at this critical point. So what we need to do is find our derivative here and set it equal to 0. So I'm going to have 0 equals, and we're going to have, let's see, the derivative of natural log of 2x. That's 2 over x, 2x, minus 1/2. And so, let's see, those 2's are going to cancel. So I have 1 over x minus 1 over 1/2 equal to 0. And so let's get a common denominator and figure out what our numerators will be. And let's go ahead and do our nice little trick in doing our fractions. We're going to multiply the denominators, and so we're going to get 2x, and then we're going to cross multiply. So we have 2 minus x, that equals 0. And the only way that could possibly equal 0 is if the numerator of the fraction equals 0. So notice we have x equals 2. Now what I need to do is go back and substitute that into the original. We know that's a critical value. And so my y value here at x equals 2 is going to be natural log of 4. And then if I plug in 2, we're going to have minus 2 and then plus 5. Okay, so, or not minus 2, sorry, that's going to be minus 1. So let's fix that. So minus 1 there. And so when we put all that together, we have the natural log of 4, and then we're going to have plus 4. So now we're wanting the maximum area. So that's the highest that our y values can go. So now let's look at the area formula of a triangle. So that area is going to be 1/2 the base times the height, and we're looking at the maximum height. So it's the natural log of 4 and then plus 4. So those are going to cancel, giving us 2. And so with our distributive property, we're going to end up with 2 natural log 4 plus 8. And so that's going to give us answer choice C. Okay, moving on to our next problem. We have the inverse. And to help us remember how to find the inverse of a function, we do need to remember that inverse means that f of g of x equals 1. And so, or not 1, it equals x. And now we do the derivative of both sides. So we're going to have f prime of g of x times g prime of x. We have to make sure we do the chain rule. That equals 1. And then solve for g prime at x. So g prime at x is 1 over f prime of g of x. Now we have our formula that we need to plug into. G is the inverse. What is the value of g prime at 2? So g prime at 2 is 1 over f prime of g of 2. And so let's see if we can't go find that answer. So 1 over, and let's see, g at 2 we're given. G at 2 is 0. So now we need f prime at 0. We're given the function f, so let's quickly go through and find f prime. That's going to be 3x squared plus 4. And so f prime at 0 should be 4. So we end up with 1/4, which is answer choice C. Alright, so for number 30, which of the following limits is equal to? And so this looks absolutely horrible to try to figure out, but there's a few ways that'll help us see what the actual value needs to be. And so this out here, that dx, that's your changing of x's. Now, a lot of this hinges on our endpoints. Notice 5 minus 2, that's going to give us 3. So the first thing we need to look for would be the information containing 3. So that's going to eliminate A, and it's going to almost eliminate B. Now we don't have a 3 on the inside, we do on the outside, and so we have to be careful with that. We really need that 3 to show up in both places, so inside and outside. So notice that that 3 is not showing up on the inside of this, so that's going to cause an issue with that problem, so that one's going to get thrown out. And then notice here we do have a 3 here, but we don't have the 3 out here, so that's gone. So the only one that has the 3 in the both places like we need it is answer choice D.